All right, guys, today we are going to be looking at examples when we are dealing with two radicals. So when we have radicals on both sides of our equation. And now how do we approach that when we're going to solve for x? So go ahead again, pause this video and take the time to write down these two examples here. So we've got two examples we're going to be looking at. So go ahead, pause, and take a second and write these two examples down. All right, so as a reminder, when we are dealing with radicals, to undo a radical, to get rid of it, we need to raise it to a power. So cube roots, we raise it to the third, square roots, we raise it to the second, and so on and so forth. And so let's go ahead and look at this first example. We have 5 times the cube root of 5x, which equals the cube root of 15,625. And so we want to, again, get to x, and looking at where x is, it's underneath our radical. And so I know we have this 5 out front, but if we were to try and divide by 5 first, we're going to be left with a 5 over here, right? We can't put a 5 into this because this number's stuck in jail, right? Both of these are stuck in jail, so moving this 5 over here, right, dividing it, that's not going to do anything. So instead, I want to tackle my radicals first, and I want to get rid of those. So I have the cube root. So to get rid of the cube root, I'm going to raise this to the third power. What I do to one side, I also must do to the other. But here's the thing. This 5 out front also needs to be raised to the third power. Every single piece of my equation needs to be raised to the third power. So in your calculator, you can either do 5 times 5 times 5, like if you have your phone calculator, or if you have a graphing calculator, you can use the caret key to get you an exponent and do 5 to the third, which will get us 125. Okay, so I've got 125, and I'm still multiplying this by this right here. But here's what happens. The cube gets rid of the cube root, and I'm left with 5x. Now, we want to keep this 5x all together, so I'm going to go ahead and put that in parentheses. Equal to, now if you're thinking, well, this to the third power, that's ginormous, you're right, that is too big of a number. We instead here, our cube is going to cancel with the cube root, just like what happened here. And so I'm going to be left with that 15,625. And then we want to go ahead and use our skills that we know to solve for x here. So I'm going to go ahead and simplify this multiplication here. So I have 125 times 5, which gets me 625x, equal to 15,625. And then I want to go ahead and solve for x. So I'm going to undo multiplication with division. So I'm going to divide both sides by 625. So 15,625 divided by 625. And so I get x equals 25. Now pause real quick. There's something we need to check, right? We have to make sure that our answer is correct, that our answer is true here. So as a reminder, we need to take this and plug this back into our equation here. So I have 5 times the cube root of 5 times my x value of 25 equal to the cube root of 15,625. All right, so I'm going to go ahead and double check this. So cube root, remember in your graphing calculator, math, option 4 here will get me the cube root of 15,625, which comes out nicely to 25. And then I want to go ahead and find this right here. So 5 times the cube root, 5 times the cube root, so option 4, 5 times the cube root of 5 times 25. And that also comes out to be 25. So nice and easy there, 25 equals 25. This is true, so I know that this is my answer. We do not have an extraneous solution here. All right, number 2, let's go ahead and look at this example. Now notice I just have the square root equal to the square root. I don't have any numbers out front like what I did with number 1. And so looking at this one's a little bit different though because I have x's on both sides. So our goal is to still get x and figure out what x is. And in order to get to that x, I need to go ahead and get rid of these radicals by raising them both to a power. And in this case, I'm going to raise it both to the second power. Here we go, focus. I'm going to raise them both to the second power because I'm dealing with square roots here. So my square root and my squared cancel. And so I'm going to be left with 2x plus 40 equals negative 16 minus 2x. And here's where you kind of got to use your algebra skills. We've got like terms on either side of this equation, and so we want to go ahead and combine those by doing the opposite still. So I'm going to go ahead and move my negative 2x over to this side by adding 2x. So then that will cancel. And I want to move my positive 40 over to the other side by subtracting 40. And then that will cancel. So what this gives me here, 2x plus 2x will give me 4x equal to negative 56. And again, all I did here was I just combined like terms by moving my x over and then moving my constant over. All right, last step, go ahead, solve for x. So go ahead, divide by 4. And so we get x equals negative, let me see here, 16, I believe. Yep. Oh, no, 14, sorry. X equals negative 14. Yep, 14. And again, we want to go ahead and double check this. So I'm going to go ahead and take negative 14, plug it back into our original here. So I've got the square root of 2 times my new x value equal to square root of negative 16 minus 2 times negative 14. And then we can do this just one side at a time, right? We can't type this whole thing into our calculator. So again, all I'm doing right now, I took our answer, I'm replugging it back into our original because I want to make sure this comes out true. So I'm going to go ahead and do this left side first. So I've got the square root of 2 times negative 14 plus 40. And this comes out to a weird number, but that's okay. We're going to do the other side here in a second, 3.464. And we want that to be the same over here on the other side. So square root again of negative 16 minus 2 times negative 14. And so when we type this in, looking in our calculator, we also get 3.464, right? We're getting the same thing here. So this is true. So x equals 14 is my answer. All right, guys, so these are 2 examples here. Again, when we have radicals on both sides, we need to undo those radicals first to get x by itself. And remember, when we have a number on the outside, we also have to raise that number to a power as well. All right, go ahead, use these notes to help you on your practice for today.